Steps for solving 2D equilibrium problems. You got to draw the free body diagram. It is more important than ever to draw the free body diagram. Don't be the person taking statics for the 6th time. Draw the free body diagram. Keep the part you're keeping. Get rid of the parts you're getting rid of. And at any cut surfaces or any cuts that you make when you draw your free body, that's where your force vectors show up. Then, after you've drawn your proper free body diagram, you apply your 3 equations of equilibrium to solve for the unknowns. And you often sit back and say, where should I, a moment equation will get you there fastest often. And you'll be like, where should I sum moments about? Normally you want to pick the point that you don't want the values for. Like if I say, what's the reaction at B, and I'm not even asking you for the reactions at A, some moments about A, right? Or maybe more illustrative is if I said, what is the force at the reaction force at point A? Don't be the schmuck that sums moments about point A, because the one value you're not going to get is point A's value. You'll end up getting point B's value, and then you'll be like, oh, wait, yeah, well, now I can sum forces in X or Y and get A. And then that's true, you can. It's just going to take longer. Moment equations are great. Think of them first. Sometimes, every problem is going to be a little bit different. Sometimes you can solve a force equation straight out of the gun. But oftentimes, you're going to need a moment equation to get you started. So just be cognizant of that. Remember to check if the structure is indeterminate or determinate or unstable before you get started. A lot of the questions you're going to be asked aren't really asking if they're indeterminate or determinate. Usually you can assume the problems in here unless they're saying, is it determinate, indeterminate, or unstable? Usually they're statically determinate because this is statics, right? But what I'm saying is in real life, if you're going to analyze something, don't start going and going and going and then realize that the thing is indeterminate and you've been spending all this time looking at it. So just always have that check up front. Do I think this is indeterminate, determinate, or unstable? How many unknowns do I have? And it'll save you some time. While you should know how to properly orient all of your unknown reaction vectors, you won't always know the sense, whether they're positive or negative. Sometimes you'll know it by feel, but other times you won't. What I'm saying is that reaction vector pointing up in the positive Y, or is it pointing down in the negative Y? You need to know that there is or isn't a Y vector there. Like a pin support has an X vector and a Y vector. But you don't necessarily know which way they're pointing. I even talked about that in the previous slide, where here I said this RAX is actually pointing the other way. It's good to make a gut decision up front which way you should point them, but if you point it this way and it turns out to be wrong, it's fine, because what's going to happen is when we do sum of forces in the X equal to 0, I'm going to have RAX plus 1.7 kips times the cosine of 30 equals 0. I'm going to get that RAX equals the negative of all that value. And then I'm like, oh, yeah, the arrow is pointing the other way. No big deal. I drew it this way, so I'll stick with it being pointed this way. I'll say equals negative, and then I'm good. So in general, just guess a sense for the vector if you don't know it. And then if the answer turns out to be negative, then you just, the arrow is really supposed to be flipped. I don't usually flip them because then you'll be like, wait, is it a negative of the way I redrew it, or is it a negative of the original? I usually keep the original sense. If the vector was pointing up and it turned out to be negative 3 kips, and sum of forces in the Y direction up positive, I will put in the vector. I'll say, well, it's pointing up, so it's going to be positive, and it has a value of negative 3. That's how I do it.